measurement of change in internal energy and change in enthalpy of the reaction or during the chemical reaction. So which is which is said to be calorimetry. So calorimetry is the technique of measuring heat changes, heat energy or heat energy changes, heat energy changes during physical process, physical process or chemical process, chemical process. The technique or the method is called calorimetry. This is called calorimetry, we say. So during the physical process and during the chemical process, the energy change takes place. That energy changes can be measured in terms of calorimetry. This can be done at constant volume, and this can be done at constant pressure it can be done. So this calorimetry is carried out in special instrument is called calorimeter. So if the value is kept constant in the calorimeter, then that instrument is called bomb calorimeter. Then by using bomb calorimeter, we can measure change in internal energy, which is equal to heat energy change at constant value. So if the heat energy change takes place at constant pressure, then the change in energy is equal to enthalpy change. So let us discuss how this bomb calorimeter will work by using by using this diagram. Let me explain so how this bomb calorimeter will work. Now look at this picture in which the calorimeter is shown to you. So and this this is the calorimeter. This is a calorimeter. So consisting of two parts. So the central part consisting of bomb. So outer part is said to be calorimeter. Okay. Now look at this. In this calorimeter, there is fixed volume of water is taken. H2O is taken, fixed volume of water is taken. So in this, here is the what is taken in this box, what is taken with the fixed value. So, and in this water, there is, this is said to be bomb. This is said to be, so bomb. So a cylindrical box is placed inside. And in this, the oxygen gas pressure will be maintained for combustion. There is firing leads will be present. There is here is the, so sample, the place for the sample. So where the combustion or burning of the sample takes place. Chemical reaction takes place here. There is a stirrer to maintain uniform temperature of the water, initial temperature. So stirrer is present and there is a thermometer is present to measure the temperature. For example, initial temperature is T1, and after the chemical reaction, the temperature changes from T1 to T2, temperature changes. By monitoring the temperature change from T1 to T2, so then we can get delta T difference, temperature difference we can get, so which is equal to QV. So as you know that a heat energy change at constant volume is equal to heat capacity at constant volume multiplied with delta T, you know this equation, which is equal to change in internal energy. For example, let me take one example of, so if I take 1 gram of graphite solid is burnt in this bomb, in this combustion chamber, so or in the bomb, so with the help of these firing leads and in the presence of oxygen, 1 gram of graphite is burnt in the presence of oxygen. So for complete combustion to form CO2, so and during this combustion of the graphite, in the presence of excess amount of oxygen to form CO2, so heat change, so Q change at constant volume, which is equal to CV and into delta T. The temperature, so T1 equal to how much? 298 Kelvin, for example, initial temperature. So at 1 atm or 1 bar pressure, so the reaction is carried out at 298 so Kelvin temperature T1. So once after burning of this graphite into CO2, so in the combustion, the heat energy released, Q is released, that pass into where? Into the water, surrounding water. Then temperature changes into T2, which is equal to how much? So 299 Kelvin, for example. So how much change temperature? 298 to 299 Kelvin temperature change. So then by using this equation, so and the heat capacity of the bomb calorimeter is how much, for example, so 20.7 kilojoules per mole. So here is 20.7 kilojoules, sorry, per Kelvin. So this is the heat capacity CV of this bomb calorimeter. So during this chemical reaction, the system, the chemical system, so chemical system loses energy. So then QV is equal to minus CV. I'm taking CV into delta T. I'm using this because the chemical system, while burning, undergoing combustion, energy is lost. That energy is absorbed by the calorimeter. So then QV is equal to, so the bomb calorimeter is minus 20.7 kilojoules per Kelvin multiplied temperature difference how much? So 299 minus 298 Kelvin temperature change. Then QV is equal to, so how much will be the 20 minus 20.7 will be the answer. So that means energy absorbed by the water or bomb calorimeter, then QV is so equal to this much, or this is equal to change in delta U. Change in delta U, so which is equal to change in enthalpy of the reaction. So if there is a more change in the temperature, so then energy difference, so heat energy change will be the more. So similarly, so here I took for 1 gram. So 1 gram I took, and if it is for the 1 mole, then this is multiplied with so 1 mole of graphite is equal to how much? 12 grams. So then 12 grams multiplied with 20.7. So minus 20.7. So we will get 2.48 into 10 to the power of 2 kilojoules per Kelvin. We'll get the answer. So that means here the chemical system that is burning inside this bomb loses heat energy. That energy captured by the water, then the temperature changes from T1 to T2, it will changes. The difference only what we call means temperature difference. So is equivalent to how much QV, and which is equal to change in internal energy of the system. So the change in internal energy can be measured by change in the heat energy during the reaction that comes from the combustion of the sample, comes a combustion of the substance in the calorimeter. So calorimetry is the process of method of measuring the heat change during the chemical and physical process. So by using special instrument called calorimeter, so and if you use the fixed value of the